Okay, welcome back. Happy Monday. Today we are covering lesson 22, which is day 1 of graphing parabolas. You will notice that coming up in a few classes is day 2 of graphing parabolas, but it's not next class. It's a little ways away. So we are we are kind of in the middle of our new theme about quadratics and parabolas. Quadratic, 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 parabolas. So lots of stuff about quadratics and parabolas in the coming classes. Our next quest is not until November the 20th. I think that's a week from Friday. That sound right? November 20th, a week from Friday. Also note that this coming Wednesday, there are no day classes in honor of Veterans Day. Does anybody have a Wednesday night class? Yes, you go to your Wednesday night class. That is on as scheduled. Just day classes are canceled Wednesday, so we won't see each other again until Friday. Questions on the calendar? Okay. Then on page 165, we will start with our new topic of graphing parabolas. Here we go. Daily summary. In this lesson, we learn how to graph quadratic equations. Number 1, in this lesson, we will graph quadratic equations of the form y equals ax squared plus bx plus c. Remember, a, b, and c are just numbers. The real variables there are x and y. We call the shape of the graph of a quadratic equation, that's one of these guys, a parabola. So taking a look at number 2, we've got 3 equations. Instead of saying y equals 4x squared minus 4, it says y1 equals 4x squared minus 4. That little subscript is just counting. It's just a y. But I've got 3 equations. So I've got a y1 equals, and I've got a y2 equals, and I've got a y3 equals. And they are graphed here in this picture. And we're just going to make some observations here about these 3 graphs. First of all, everything we've graphed so far this semester has been what? Linear. Every graph I've asked you to draw has been a straight line. All of a sudden we have curvy things. They're more complicated. The equations are more complicated, and graphing them is going to be more complicated. Again, the graphs are here. Here are called parabolas. So first observation about the graphs here is to figure out which equation goes with which of these 3 graphs. And what we're going to do is find the y-intercepts of each of the graphs. So to find the y-intercept, well, you've known how to do that for a long time. How do you find the y-intercept of anything? We let x equal 0. That's an old process, right? To find the y-intercept, you'd let x equal 0. To find the x-intercept, you'd let y equal 0. So let's just let x equal 0. So for y1, just copying this equation right here, but change that x to a 0, we get 4 times 0 squared minus 4 is negative 4. So whichever graph is y1 has to have a y-intercept of y equals negative 4. You have a guess? What color? This one is blue, right? I'm looking at it's the only one that could be negative 4 when it crosses the y-axis. So I'll label this guy right here as y1. Next one, y2 equals, now it's this equation. Again, changing the x to 0 because that's always how you find the y-intercepts. So we get 0 squared minus 14 times 0 plus 60 is 60. What color has a y-intercept of 60? Green. So green must be y2. There it goes through the 60 right up there. And then maybe we're ready to recognize the shortcut here. The y-intercept of y1 was negative 4. The y-intercept of y2 was 60. See the shortcut here? What's the y-intercept of this last guy? Negative 25. It's just that the number that doesn't have any x's on it. Okay, so that's fine. So this one is negative 25. Negative 25 is right down there. And so I guess that makes that pinkish thing y3. Okay. All right, next observation down here in 3a. 2 of the graphs above open upwards like a smile, and 1 graph opens downwards like a frown. Whether you have a happy parabola or a sad parabola is completely determined by the value of a in the equation. Let's just grab the values of a from the beginning here. Remember, the equation is this. That's our general equation. A is always the number touching the x squared. How much is A in this first example? It's the number touching x squared. Or how much is A in the second example? 1, it's invisible. And A in this last example, -1. Good, grab that negative sign. And then 2 of those parabolas open upwards like a smile. And 2 of those numbers that we just wrote down are what kinds of numbers? Positive numbers. That's all we need to know. To decide whether the parabola opens upwards or downwards, you just have to decide whether A is positive or negative. For the 2 upwards parabolas, y1 and y2, A was a positive number. For the 1 downwards opening parabola, A was a negative number, which works out kind of nicely for this analogy. If A is positive, then the parabola opens up. Remember, positive people are happy. If A is negative, the parabola opens down. Remember, negative people are sad. Good? Okay. Part B talks about x-intercepts. Let's take a look at them. The blue parabola has how many x-intercepts? 2. The pink parabola has how many x-intercepts? Looks like 1, maybe. It's hard to know. We'd really have to kind of zoom in there, but I'd buy it. It could be 1. And the green parabola has how many x-intercepts? None. Now this is quite different from all of our experience with lines. If you draw a line, how many x-intercepts does it have? 1. Is that the only possibility? Could it have 2? Not a linear thing. Could it have none? What kind of line would have no x-intercepts? A horizontal line. So that is, there is a special line out there. It's a horizontal one that has no x-intercepts. But if you just draw an arbitrary old line there, it's going to have exactly 1 x-intercept, which is quite different from our parabolas, which either have 2 or 1 or none. A lot more variety. Okay, we'll figure out how to find those x-intercepts momentarily. Let's take a look at the extreme points on these parabolas. I will mark them in what color? Orange. So that point right there is the lowest point on that parabola. This is the lowest point on this parabola. Now our sad parabola, the one that looks like a frowny face, doesn't have a lowest point. It has a highest point. Yes? So every parabola either has a lowest point or a highest point, and that particular point has a name. It's called the vertex of the parabola. Vertex. And if we wanted to find the vertex, well, we'll have a process. We'll have a couple of ways to do this, but our initial way today is to take a look at the x-intercepts when it has 2 of them. Looks like the x-intercepts here are 1 and -1. Do you guys buy that the vertex is halfway right in the middle of 1 and -1? Yeah? And so that's going to be the way that we'll find the vertex, is we'll first find the x-intercepts, and then we'll just go smush right down to the middle. That's where the vertex has to be. Now that works great if we have 2 x-intercepts, but it doesn't work so great in the green picture where we have no x-intercepts to find, right? We'll need a different technique. We won't have that today. Soon though. Okay, I think that is all good. Let's get our hands dirty and try to graph one of these ourselves. Again, taking a step back to graphing lines, which is something we've done all semester. How many points do we need to plot in order to graph a line? Just 2. And so maybe you would find the x-intercept, and you'd find the y-intercept. You'd get your straight edge and you draw your line. Just 2 points is enough. For parabolas, it's a more complicated graph. We're going to need more points. Our default is going to be 5 points. And I'm going to show you the 5 points that we usually find. Sometimes we can't find all 5 of these and we'll just settle for different points, but it's no longer 2 for us. We're looking for 5. Okay, there is a 6-step process on the next page. You can take a look at it for reference, but we'll just run through it here together as we graph this example. Y equals -x squared plus 4x minus 3. The first question, does this parabola open up or down? What am I looking for in the equation to decide if it opens up or down? Is a positive or a negative in the front of that x squared, right? How much is A? -1. Is -1 positive or negative? Negative. So the parabola opens which way? Down. It is negative, it is sad, it opens downwards, okay? On the next quest, you're going to draw at least one parabola for me, and I'm going to ask you, does it open up or down, and why? And almost all of you are going to tell me correctly that it opens up or down, but some of you are not going to answer the why question. And the why answer is very short. This is a full credit answer here. What part of this says why? The less than 0 part. That says why. That's all you got to write. It's not a lot, but it's going to be worth a point to some of you if you don't include it. Okay, let's find the y-intercept next. In order to find the y-intercept, we did this on the previous page. What variable equals 0? Is the x. So we're going to let x equal 0. So this becomes a 0, and this becomes a 0. And what does y equal? -3. And so all of a sudden we have a point that is right there. X was 0. Y turned out to be -3. Let's plot that point on our axes, 0 and -3. Okay, next part of our process is finding the x-intercept or intercepts. There could be two. In general, how do we find x-intercept of a line? 0 for y. It's the same exact process here. We're going to plug 0 for y. So go back to the original equation. This guy right here becomes 0. That new equation is written right down here, right? 0 equals -x² plus 4x minus 3. And now we have a problem that looks familiar. We solved problems just like this last class. 0 equals some quadratic. Our technique at this point is to factor. So let's try factoring. We'll use the box here. I've got us started. Top left, we put the -x². Bottom right, we put the -3. And I multiply that diagonal, and I get a +3x². Yeah? And so I'm just going to list all the ways to build a +3x². There's not many. What are they? Can do 3x and 1x. One more. -3x and -x, right? So those are the ways to multiply to get 3x². One of those pairs is going into my blanks. How do I know which one? We need them to add to this 4x here, right? And if you add these guys, we get our winner. If you add these guys, we get a pretender, -4x. So in these two blanks goes 3x and x. It makes no difference, but let's just all put the same thing so we're looking at the same thing. 3x and x going in that order. And I know that some of you are now pros at the box, but some of you still need a little bit more practice, so let's do this together. First row is always where I start. I recommend you do the same thing. Greatest common factor there is x. Sounds good to me. Then I'm going up here, trying to build the -x² in that corner. -x looks good. And then I'm going up here, trying to build the 3x, using the x at the far left. What is it? I want you to say more than just 3, but +3, right? Let's get that sign in there. And then some people struggle on this one because everything so far has been built off of that x, but this last guy has nothing to do with that x. This last guy is built from the -x at the top. I'm trying to build this x down here. What does it have to be? -1 is good. Right? And then we check the bottom right. Did it work? -1 times +3. Good. So we've got our winner. And so we'll write down our factors. First factor is from the left, x minus 1. And then from the top, -x plus 3. And what was it equal to before? 0, and still equal to 0. All we've done is rewritten the quadratic, -x² plus 4x minus 3. But now it's in factored form. Okay, and I mentioned this last time. I caution you against memorizing, whatever the factored answers are, just change the numbers and that's the answers to the problem. It works here. What's the value of x that's going to make the first parentheses 0? is 1. So x equals 1 is fine, but if you change this plus 3 to a minus 3 and you write x equals minus 3, you're wrong. That shortcut doesn't work all the time, so I just wouldn't even mess around with it at all. I would just write down two equations. It doesn't take long. 0 equals the first thing, 0 equals the second thing. Over here, add 1. Over here, maybe add x. Get x equals 3. The thing that started us on this part of the problem was letting y equal 0. So in terms of writing both coordinates of these x-intercepts, they're both going to involve y equals 0. This guy is what ordered pair? 1, 0, and this one is 3, 0. It's really tempting. You have x equals 1 and x equals 3, and I tell you to write both coordinates, you might say, oh, 1, 3, or 3, 1. It's not. They're both x's. They don't go in the same point. So those are our two x-intercepts. Go ahead and plot those 2 points on our graph. Okay, so we'll pause for just a second. That is the hardest part of this whole process. Finding x-intercepts involves solving a quadratic equation equal to 0, which typically involves factoring, which is a big process, okay? It's supposed to take time to find the x-intercepts. Now, some of us might be a little bit troubled by the graph here because the two x-intercepts, like I can in my mind envision a parabola that looks like that, and it isn't going to hit this y-intercept down here. And if I was just trying to hit the 2 points on the left, I might envision something like that, but that isn't going to turn around and hit the point on the right. What's wrong with the two parabolas that I've just drawn? Yeah, they're supposed to open down, right? I had in my mind this thing opens up, but it doesn't. And so as soon as you relax that condition, you say opens down, well, maybe now you start to see, oh, okay, it's going to be something like that, right? But let's just get a little bit more info before we commit to it. Okay, the next thing we're looking for is the vertex. I'll draw this and then I'll erase it. But the vertex, remember, is either the highest or lowest point. In this case, it's the highest point. And that vertex lives smack dab in between the two x-intercepts. X-intercepts are at 1 and 3. Where's the vertex? 2. In this case, it was pretty easy to just know that 2 was smack dab in the middle. But if the numbers were a little bit more complicated, like 1 and 3, like if there were some fractions, I just want to make sure we have a process that will find that number right in the middle, even if the numbers are messier. So how do you find the number that's halfway in between two other numbers? You average them. Yes? The average of 1 and 3 is 1 plus 3, and then you divide by the two numbers, right? Okay, so again, it's silly. I mean, like we just know this one is 2 because it's obvious, but if I gave you the x-intercepts were 1/3 and 4/5, and I say find the number in the middle, I would recommend doing this formula where you add them and divide by 2, just the average. Okay, so sure, the vertex is at x equals 2. Just some notation here. That's my way of saying the x coordinate of the vertex. The little v is my way of indicating we're talking about the vertex. Okay, so the x coordinate is at 2. That's great, but what else would we like to know about that vertex? Just the y coordinate, right? All I know is at the moment the vertex lives somewhere on this line, but I have no earthly idea how high or low that vertex is. So how are we going to find it? Well, we know that x equals 2 at the vertex, and we also know that this guy gives the relationship between x and y for any point on your parabola. And so if x is equal to 2, we can just plug x equals 2 into that, crunch the numbers, and we'll find the y value, yes? Just like for lines, you can plug in any x you want and you can find a y. Same thing for parabolas. You can plug in any x you want and find the y. We're going to plug in x equals 2. I'll do it up here. Y equals negative 2 squared plus 4 times 2 minus 3. Everybody see what we did? Just substitute 2 for x. So that's negative 4 plus 8 minus 3 what is that? That 1? So the y coordinate of that vertex is at 1. Ryan, is that all right? So putting the two pieces together, the two coordinates of that vertex, we found that the x was definitely 2. We plugged that 2 into the original and found that the y was 1. And so pushing those two guys together, we get the vertex is at 2, 1. So plot that point, 2, 1. 2, 1 is here. Great. So the parabola is really taking shape. We probably have enough information to just draw something that connects the points. But I had said at the beginning of this process that we're going to find 5 points. We've got 4. The last one is actually pretty easy to find. I'm going to draw this dotted line going right through the vertex. And then I'm going to draw the parabola, which I will erase because, like I said, I want a little bit more info. But would you guys buy that that parabola is perfectly symmetric over the dotted line? It's like two mirror images, exactly the same thing. So then all we're going to do is make sure that any point that we plot, we're also plotting its mirror image point. What's that? We're not going to find the slope. Which point are you wanting to find the mirror image of? Yes, that's what we're going to find. Yeah. Right, and so the only point that doesn't have a partner right now is that 0, -3, right? That y-intercept is missing its partner. So all we have to do is find the coordinates of its partner, and we're just going to use symmetry. How far is it to get from the y-intercept to that axis of symmetry? 2. So then if I'm going to the partner point, it's going to be another 2, and it's going to be the same horizontal level as before. So what are the coordinates of the partner? 4, -3. 4, -3 is the symmetric partner of the y-intercept. So we're always just going to plot that extra point, find the partner of the y-intercept. And then we connect the dots. So go ahead and connect those 5 points. You're going to draw something that is curvy and smooth. Some people get really judgmental about how badly they draw parabolas. Don't worry about it. You are far more judgmental about that than I am. But there are 2 things that I will judge harshly for in terms of taking points off on a test. Number 1, I do not want to see that. Parabolas are curvy and smooth, not jagged and cornered, okay? So don't do that. And the other thing that I don't want to see is this, which if I'm being honest, that looks pretty darn good to me, but what's the problem? It doesn't go through, right? The parabola doesn't just die at the last points that I plotted. So in the same way that I ask you to draw your lines all the way across the grid, I'm going to ask you to continue your parabolas all the way across the grid, okay? Questions on any of that? Okay, answer key is right there. That is exactly the 5 points that we plotted, connected with some smooth, continuous curve. All right, so the process is written out in all its detail there on page 167, so you can reference that while you're doing the activity or doing the homework tonight. Go ahead and move to the activity on the next page.